let's say we have the line y equals 2x minus 1 and we have another line that's y equals negative x, let's see, plus 5. And we want to figure out where these two lines intersect. And so we can do this either graphically by simply graphing both lines, or we can use methods in order to solve algebraically for the intersection point. So now that we know that these two lines are equivalent at the point of intersection, we can use something called substitution. So let's call this one y1 and let's call this one y2. So we're just giving some arbitrary name to each of these lines, and so we can use substitution. So let me write y1 right here. So we know that y1 is equal to 2x minus 1. And once again, we know that y1 has to equal y2 at the point of intersection, because let me just draw two lines. Let's say we have this line and we have this line. This is their point of intersection, and they have the same y value and the same x value at this point. So now let's get back to the problem. So now we know that the y1 has to equal to y2. We can do some substitution. Well, we know y2 is negative x plus 5, and we know y1 is a 2x minus 1. Sorry about that. So let's rewrite these with in terms of x. So we know 2x minus 1 is equal to negative x plus 5. And now this looks like a fairly simple linear equation to solve for x. So let's go ahead and solve. So we're going to add x to both sides. You have to get the x's on one side and the constants or the numbers on another side. So let's add that. So we get 3x minus 1 is equal to 5, because that cancels. Now let's add 1. Oh wow, look at that, we're not going to get a fraction. Beautifully designed. So now we add 1, that cancels. 5 plus 1 is 6. 3x equals 6, and x equals 2, because we divide by 3. That cancels. 6 over 3 is 2. So now we have our x value. So this is the x coordinate of the point of intersection. So now that we have this, we can solve for the y coordinate. Once again, we know that the y values and the x values are equivalent at the point of intersection. So what we can do is plug it into one or the other and solve for y. So this one looks easy. Let's plug it into this one. So we know y is 2x minus 1, and we know x is 2. So y is actually both y's in this case. So y is 2 times 2 minus 1, which is 4 minus 1, which is 3. So our point of intersection is 2, 3. And now let's check our answer. So we know that the point of intersection is 2, 3. Now, how do we check that? Well, we know that both lines have to go through this point. We know that both lines have to go through this point. So therefore, what we can do is plug it in and see if we get equivalent expressions. So we know that 3, so let's plug in right here. So 3 has to equal 2 times 2 minus 1, because 2 is x and y is 3. So 3 is equal to 4 minus 1, 3 is equal to 3. Boom, we checked our work. Let's do it for the second one. Once again, we know 3 has to equal negative 2 plus 5. So 3 is equal to negative 2. I'm just plugging in x and y for the x and y values. So 3 is equal to negative 2 plus 5. 5 minus 2 is 3, so 3 equals 3. Boom. So that works as well. So this method is called substitution to solve for the point of intersection.